Hi there, welcome to this series of videos on programming logic. We would start with simple programs like even numbers, odd numbers, how to find if a number is prime, find factorial of a number, and then move on to complex data structures and also algorithms. In this video, let's write a program to convert Celsius to Fahrenheit. If you look at the logic to convert a Celsius to Fahrenheit, it's very simple. All that you need to do is take Celsius and multiply it by 9/5 and add 32 to it. I could have written something of this kind, so Celsius into 9/5 plus 32, but it's confusing. You have no idea whether plus gets executed first, slash gets executed first, or star gets executed first. So to make it very simple, I've added brackets in. So the first thing which gets calculated is Celsius into 9/5, and to that 32 needs to be added. The program, I've created a simple function Celsius to Fahrenheit. Right now it returns a value 0. So I've just created a float 0.0 and written the Fahrenheit back. From main, I've just invoked that function passing in the value. So if I run this program right now, if you look at the output, it would just show me 0 degrees Fahrenheit. So the actual logic of the program is not implemented yet. That's why we see the output showing 0 and 0. So now let's go ahead and try and implement the logic. So the value of Fahrenheit is, as we looked at earlier, it should be Celsius. I have the input, the argument passed in, Celsius, into 9/5. So Celsius into 9/5 plus 32. So that's the value which we are returning back from here. So let's just check if I get the right value. Let's run the program and check whether the output is right. So if I run the program, I can see the output here. It shows 32 degrees Celsius is equal to 64 degree Fahrenheit. Minus 40 degrees Celsius is equal to minus 8. But actually this is not right. The value for minus 40 degrees Celsius should be actually minus 40 degree Fahrenheit. So that's something which I know because that's the only point where the Celsius and the Fahrenheit scales meet. So there is something wrong in the way we did the calculation. The place where we did a mistake is here. What happens is any operation involving integers in any programming language, I think C, C++, Java, returns you an integer back. So what happens when I do a 9/5 here is actually 9/5 is 1.8, but since 9 is an integer and 5 is an integer, what happens is the decimal gets truncated. So 9/5 is equal to 1.8. The decimal part is truncated, that becomes 1. So whatever output we get is 1.8, but that's converted to 1, and 1 is used in the calculation. To make sure that something, to make sure that it's a floating point calculation, I would make one of these or both of them float. So I can do this 9.0 by 5.0. It's enough even if I do one of them to a floating point. So I'll also convert this to floating point because I want floating point addition here. Anyway, floating point addition would happen because the result of this would be a float. So even if I leave it at 32, float plus int is a float. So that won't be a problem, but just to be safe, in all floating point calculations, it's better to use floats. Okay, let's run the program and check what the output is. If you check the output right now, it shows the right values, 89.59. Okay, it's 89.6 and minus 40.0. So if 32 degrees Celsius is equal to 89.6 Fahrenheit and minus 40 degrees Celsius is equal to minus 40 Fahrenheit. So that's basically a simple function to convert Celsius to Fahrenheit. If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.